So in this example, the first thing we want to do is find the critical numbers of the function. And remember, critical numbers are just numbers x that are in the domain of the function. And they also satisfy that either f prime of x is equal to 0 or f prime of x is undefined. Okay, so we want to find the critical numbers, and then after we find the critical numbers, we want to find the absolute maximum and minimum values of the function on the given interval. So here's our function. Normally I wouldn't graph a function first, but this function is an absolute value composition. So I am going to just graph it first so you get a sense of what's happening here. So remember that in order to graph a function that involves absolute value, we're first going to take a look at the graph of the function that is inside the absolute value. So this is just the function y equal 8 minus 4t, and hopefully you recognize that as a line. So, okay, and that line has slope equal to, so let's see, that line has a y-intercept of 8, okay, and it has a slope of -4. So we're going to go down 1, 2, 3, 4, and over 1 point. Okay, and then the line passes below the x-axis. So it's just a line. Now, when I add the absolute value here, what happens is that any portion of the graph that lies below the x-axis gets reflected across the x-axis. So this graph is going to look something like this. Okay. And that would give me the graph, and I'm just going to clean up this part right here. Okay, and this would give me the graph of the absolute value of that line. And this x value is 2. And just so we don't forget, recall that the original function was a line that was below the x-axis when x was greater than 2. Okay, so I'm also, in order to help us take the derivative, I'm also going to rewrite this function in a slightly nicer form without the absolute value. So f of t, now recall, I'm going to write this as a piecewise function. Recall that when the inside part, 8 minus 4t, is positive, then the absolute value of that quantity is just equal to that quantity itself. And recall that this quantity was positive over here. You can see the graph is above the x-axis, and that occurred when x was less than or equal to 2. Also notice that when this quantity here is negative, the absolute value is going to return the opposite of that quantity. So we have f of t is equal to the opposite of 8 minus 4t, and that's going to occur whenever when the original graph of the line was below the x-axis, so that occurred from 2 to infinity. Okay, so this is one way we can write our function without absolute value. And then that makes it easy for me to take the derivative. However, I'm first going to note that we have a sharp point here, and so the derivative is not defined at x equal 2. However, for all the other values, for example, when x is less than 2, I just need to take the derivative of this function, and I get -4. And that is the derivative when x is strictly less than 2. And the derivative of this function here is positive 4. And that is the derivative when x is greater than 2. And you can look at the graph and verify that, right? Okay, the derivative, -4 and 4. But undefined when x is equal to 2. This also tells us that there are no values at which the derivative is equal to 0. So this means that the critical number, there's only one, and the critical number is actually just t equal to 2. It occurs right where that sharp point is. The derivative is undefined, therefore that is a critical number. So let's look at the second part of the question, part B. Part B asks us to find the absolute maximum and minimum values of the function on the given interval. In order to find the absolute max and absolute min, I'm going to use the use the extreme value theorem and the closed interval method. So the extreme value theorem basically just says that if my function is continuous on a closed interval and 0, 3 is a closed interval, that was the interval we're working with, then our function must attain an absolute maximum and an absolute minimum. We saw examples previously where we had functions that did not attain absolute maxes or min, if there was an open circle. But if the function is continuous on a closed interval, we are guaranteed of an absolute maximum and minimum. How do we actually find the absolute maximum and minimum? We can use a process called the closed interval method. Step 1, you just find the critical numbers. Step 2, you just plug those numbers or evaluate f at each critical number, and you also evaluate f at the endpoints, a, b, so that's the endpoints of this interval. And then the largest value is going to be your absolute max. The smallest value is going to be your absolute min. So I'm just going to go back, and in order to do part B, I'm going to use this method. Okay, so this, recall, was our answer to part A, but I'm going to use it for part B. So let's take a look at, so we've already done the first step in the closed interval method, and now the second step is telling me I just have to plug 2, so this value, the critical number, into my function, and I get 8 minus 4 times 2, and that is 0. Now the closed interval method is also telling me to plug in these values into my function. So f of 0 is 8 minus 4 times 0. That's 0. Oh, sorry, that's 8. And f of 3 is equal to absolute value of 8 minus 4 times 3. So that is 8 minus 12, which is negative 4, or 4. Okay, so the closed interval method finally tells me that the smallest value is my absolute min, and the largest value is my absolute max. And that's all that I have to do. And I have the graph here just to sort of highlight what happened. And so if we are restricting to this interval here, then what you can see is the portion of the graph that I'm interested in is just this portion right here from 0 over to 3. So I'm really only interested in this portion of the graph. I'm just asking what is the absolute maximum value of my function and the absolute minimum value of my function on this interval. And if you just look at the graph, you can see that the absolute max is 8, f of 0 equal 8, and the absolute minimum is f of 2 equals 0. And that's exactly what the closed interval method detected for us. That this is the absolute max and this is the absolute min. This value was just sort of in between.